seen it all. So who can give me some examples of ones that we're talking about today? So who can give me an example of potential and kinetic and how they relate to each other? Poppy?
So if I had like a palm pal and it's sitting on top of a hill, it's potential energy.
Yep.
Because it's on top of the hill, it's not doing anything.
Right.
But if something pushes it and it rolls down the hill, then it's kinetic energy.
Right. So potential energy can always turn into what? Kinetic energy. All right. So let's do one more. Or two more. Let's do sound. Who can give me an example of sound energy? Eliza.
Sound energy, it's like when I play a musical instrument, like my violin.
Okay. So anyone else play an instrument? Okay. Henry, what do you play? Oh, those are kind of similar in like the strings. Does anybody play something besides the strings? Ian? Well, do you play something besides, or if you play a string, what do you play? Oh, you're so talented. And you play piano, right, Hurley? Yeah. Cool. All right. Last one, just so we can get our fun stations. Who can tell me the parts of a simple circuit? So I know we went over this briefly in our slides, but tell me the different parts of a circuit. Finn.
The wire is like the one that transmits.
Okay. What does it transmit?
The battery to the bulb.
Okay, so the energy comes from the what?
Battery.
Yep, and then it can light up the bulb, which is what we saw in our slides. It's just a basic, simple circuit, right? Okay, so today, guys, you're going to be able to explore potential and kinetic, sound energy, and a simple circuit, okay? So we have our science trios that we're using this quarter, right? So you're going to get with your science trios, and you're going to decide on who's a material manager. So that's the person that organizes the supplies on the bucket, okay, for where you're starting. We have the builder and tester, someone who tries it out. Then we're going to have someone who records and kind of takes charge and lead of how you're answering the questions, okay? So make sure we're not bossing everyone around, but we're just saying, hey guys, why do we think this happens? But everyone is recording their answers on the question, but you're going to answer them together, okay? All right, so here is where you're starting, okay? So for example, group one, raise your hand. Group one. Okay, so you're going to start at table one, okay, with the circuits. All right, group two, raise your hand. You're starting at what table?
Table 2.
Okay. Table three, group three, raise your hand. Or you're sorry, table three. Where are y'all starting?
Table 3.
Okay. Group four, where are y'all starting? Okay. Group five.
Table 5.
Sorry, you're going to have to do without since Ben's absent. And group six.
Table 6.
Group seven. Group eight.
Table 8.
Okay, well, that kind of worked out perfect, right? Okay, there is one back there, the back table. So when it says back table by the cubbies, that one will be empty to start off with, but you eventually will rotate there. So when you rotate, I will have the slides up. You're going to rotate clockwise, okay? So you're moving this way. So, of course, your group will go back that way, okay? All right, questions? We're good? Okay, so remember we're exploring. Science is all about trial and error. If something doesn't work out, try a different way, okay? And make sure we're collaborating as to why things work, why things may not work. Remember, our transitions, what do they look like? Luke, what do they look like?
Silent.
Silent. Why?
Because people might not know like where to go if everyone's talking and making shit like
Yeah, and we also want to get to our station so that we're able to do our activity, right? We want to be able to get through all three of our rotations today. All right, so you'll be at each station for about 6 minutes, okay? I will give you a 45-second warning. Hey guys, you have 45 seconds left. Make sure we are putting the supplies back nice and neat. I don't want wires on the ground or cups on the ground. We're respecting our things, okay? So I'll let you go with your trios. Let's get started. Make sure we're respectful of our volume.
would be the builder of the Tesla. Be the sword man, I think. You all agree on that? Yeah. So let's start by building this. So it says we pick up this. So I think that we put the string through it, through like a little cup, and then once we can get it through,
Try it on both ends so it stays together.
yeah. So I think it says, yeah. So
Okay,
start
we're going
with
one
it.
thing at a time.
So tie it, and then go on from there.
Oh, this thing. Yeah, but don't touch it. I'll hold it still like right here. Okay, now put it up. Now connect it.
That's good. So let's try it loose there. Like that.
Now it should not.
We gotta bend it. Like a little bit. Okay. Now let's try it.
Okay, so what made y'all try it loose first?
We can try the different ways to see like.
See where it's very loose or it's hot.
Okay.
Can you not say taut? It's kind of throwing me off.
Say what?
Taut.
No, here. Try tape it.
Just tape it. Like that. Can you hear that?
Why don't you speak it just a little bit louder? Is that whispering? Speak a little louder.
Light the light with the two wires.
Yeah,
To light the bulb.
Yeah.
So, to light
It was like
bulb with the bulb with
Sound waves travel through what? They travel through sound waves, but you kind of feel the what? But what did you notice? Did it work better with a tight or loose?
I mean, tight. On the street.
Oh, yeah, there's lighting.
or bulb.
So, how do we start this process? Walk me through how y'all started this.
First, we put the battery inside
Okay.
there and make sure the positive side is this way, the negative side is this way.
Okay.
And then we hooked the wires on this side first, and then connected it to this to make the bulb light.
So, what if I took away this wire? Would it still light?
No.
Why?
Because it needs to be a full circle.
A full circuit, right?
Yeah.
Because if I took the wire away, it wouldn't get the charge from what end?
The negative side.
Yeah, because we had the positive and the what? It's staying lit too. That's nice. Good job, guys.
Okay, our bulb did light this.
Try that. Alright, let's see if it lights up. I think we have to connect the other. Maybe. Hold on. Alright, it's touching the battery now. I think we might be able to do it. Alright, let's put it in. Okay, what did our trio notice together? That the tight string was better than the loose string? Yeah. And then I think the most you could hear it was the tight. The second most you could hear it was like just with the string, and then the line. And then when you couldn't hear it really good, it was the like loose string.
Yeah, loose.
So whatever, tight string, The kinetic was like when it was going down, and then the like potential, then they can.
Yeah. So, sentence frame. We observe kinetic and potential energy. My bad.
Okay. Ladies. So what did we notice? So what did we start off with? So we start off with our cups and our string. So did you start off with loose or tight grip? Okay. And what did we notice about the loose grip? The loose string.
You can like barely. It was that well compared to when the string is tight.
Okay. So why do you think that?
Because when she when she talked into the cup and it was loose, I couldn't hear it. It only was like a little noise, and when she tightened it, I could hear it, and I
Hear the message.
I could hear like a clear message.
So it's kind of like the game we play in morning meeting, right? The telephone game.
Yeah.
So you were able to hear her when it was tight. Let's do it.
When you pushed
Did you hear like some sort of sound? Okay.
I could hear it way better.
So you noticed it was kind of loose when I did it at first, but then I tightened it up and she could hear it, right?
Yeah.
Okay.
What is our trio?
45-second warning. I didn't have timer off, but I will not keep track of that. 45-second warning. Clean it up. Get to a stopping point. Make sure you put all the materials back where you found them.
When it was here. Then when it pushed it, it showed kinetic energy. But when it was up there, it showed potential. So the car wasn't moving. It went to kinetic energy to potential energy.
Alright. I need you getting finished in 10, 9. Remember we'll have time at the end to answer our questions if you did not get to them all. 8, 7, 3, 2, 1. Alright guys, so look at the round 2 column. That's where you're going next, and you're going moving what?
Okay, say it. So place the object down. Place the car, build the ramp, and then place the car on the
Okay, so you know what a group did over there, which I really like it. They took the books, so the car wouldn't keep going. Put it down here. Did this. I thought that was an awesome idea. Alright, so we know that we're at our energy round, right? So we think we're going to be looking at what types of energy?
potential and kinetic.
Okay, so we're chilling. So saying if we're chilling right here, what kind of energy is that?
Potential.
Potential, because that has the potential to do what?
Move.
Move. Okay, let's see what happens. Now it's what? Kinetic. How do you know that?
Because when it has the potential to move, it sits still, and then when it has kinetic energy, it
While in motion, that changes to what type of energy?
Kinetic.
No. Okay. Doing a pop and a willy. Okay, so let's look at our first question together. So, what happened when the object started at the top of the ramp? So, what happened when we had the car chilling up there?
There was potential energy.
Was it moving? No, so it wasn't moving, so it was stuck in where? Potential energy. So, where did you see that potential?
when it was at the ramp.
At the top of the ramp, right? When it was not moving. Good. Good, Ben. And then we kind of also already answered that next question. Where do we see the kinetic energy when it was doing what?
Moving down.
Moving downhill. So when you're moving downhill versus uphill, which way are you moving quicker?
Down.
But is it still kinetic when you're going uphill? It's still in moving? Because remember, it doesn't matter how fast. If you're in motion, it's still technically what?
Kinetic.
Moving.
We're working here. Oh, you know what it is? So,
Down.
The energy change.
the protection of the wire.
The difference because when it was resting on the top and when it moved, the gravity pulled it down onto the ramp. And since the ramp is on a flat surface, it went downwards. So that created kinetic energy because it was gravity pushing it down. Since this is not a flat surface, it had to go down and went down this.
So we know, so like a shorter version of that would be it changed because it moved from staying still to moving down the ramp.
So, I like how y'all did this. I know you didn't light it first, and I'm kind of glad it didn't light it first. So, it didn't light. Why didn't it light? So when y'all first did that, why did you have trouble lighting the bulb?
Because we had the red and we had like the little red in here.
And that's the casing that protects the wire, right?
Yeah.
But what has to be touching?
The
light.
The actual wire, because that's where the
battery.
Battery.
energy comes from, right? So what kind of energy? What type of energy is this? Would it be
Thermal,
heat?
Electric.
Why?
Because like the battery has like electricity in it. Makes the light light up. That helps us with that.
Oh, wow, this happened. Okay, so this wire fell out. Can it light with just one wire from one end of the battery? No, because it has to have from the positive and the what?
Negative.
Negative. It has to have energy from both sides to create energy to light up the bulb. That's so cool. They are doing like a double circuit.
Wait, what if you can
I think you probably have to like unscrew this like off to have the actual like wire showing.